Alright, hello everyone, my name is Timothy Lee Grant and welcome back to another Leetcoding video. So, as we've been doing for the past few days, this video is going to be a little bit more chill, a little bit low stress, low pressure. You know, we're just playing with it, we're trying to have fun, see if we can solve it. We're just doing easy problems right now, and the idea behind it is I want to see a wide variety of different problems, try to get it into my subconscious. If we're not able to solve it, that's fine. We're gonna learn along the way. So let's figure out which topic we want to do. I'm gonna minimize myself a little bit, and then which one do we want to do? So I did a dynamic programming, I believe yesterday. No, I did a sorting video yesterday. I did dynamic programming the day before that, and I did greedy the day before that. So let's what do we want to do? Should we just like close our eyes and randomly choose one? I think we should do that. Okay, so I have my pointer here. Here. What is it closest to? That's closest to this ordered set. Okay. And we're going to be choosing an easy, so let's remember that. So, first off, let me see if... Oh, all of those are hard. Okay, so something that I've observed is that the higher the number is, the more complicated the problem actually is. So here's the first easy that we see, and it's number 2363. So off the bat, I'm not feeling too too confident about this one, but that's fine. If we don't solve it, we don't solve it. That's okay. We're going to learn along the way, as I said. I'm going to actually make myself a little bit smaller. All right. Wait for this to load. Okay, here we go. Number 2363. What a number that is. Merge similar items. You are given two 2D integer arrays. So items 1 and items 2 are two, right, separate arrays, and each of them are two-dimensional. So we have two-dimensional arrays. Awesome. Representing two sets of items. Okay. Each array items has the following properties. Okay. So what does that mean? Each array items. So the entire two-dimensional array has two properties. What are those properties? Number one, items of I has both a value and a weight associated to that element. Okay. Where value represents the value. Okay, there we go. And weight, I'm not going to look, I'm going to guess, represents the weight. And weight represents the weight. There we go. Number two, the value of each item in items is unique. Okay, so this value here is unique for each index of this element. Okay. What do we have to do? Let's look at that. Return a 2D integer array, okay? Ret, where ret of I equals value I with weight I. Okay? So this is what we need to return. We need to return value and weight. And what does weight represent? Being the sum of weights of all items with value. Okay. So right off the bat, I'm a little bit confused about what is it actually saying? What are we trying to do? How are we... First, I can't even understand the problem right now, let alone try to think of how to actually implement the solution. But let's I'm going to reread this problem and try to figure out, like, okay, reading it a second time, does that actually help me? Does that make things more clear? Okay. You are given two two-dimensional integer arrays, items of 1 and items of 2, representing two sets of items, okay? Each array items has the following property, that they both have a weight, or a value and a weight. So every index has a value and a weight, okay? There's two of them. And values are unique. Okay. Return another two-dimensional array with value and weight. Now, weight is what we're interested in. This is kind of where the problem is. Being the sum of weights. So the number weights is a sum of all of the other weights. So I'm guessing in items 1 and items 2 with value of value. Okay, and so what I think is going on, and then we're going to look at the example problem down here, but what I think is going on is similar to this. So we're going to have items 1 is going to be equal to like this. Items 2 is going to be a list. Okay, and now we're going to have in here, there's going to be a whole bunch of different elements, okay, like that. And then items 2 is also going to have elements. Let's say that there's only 3 in here. So what do we want? We want weight, or we want value first, and value is unique, correct? Yeah, value is unique. So value, does it say anything about like that they're sorted in any way? No. Okay. So I'm going to do it all haphazardly because it doesn't say that it's sorted. So I'm going to say 99 for value, and then I'm going to say weight is 3. Okay. Then I'm going to come here. Now it's just 8. Okay. And value 200. Okay. And then weight of, or value of 62 and a weight of 3. Okay. And 7, 9. What's one that I have not chosen? Have I chosen a 1? No, I have not. And 5. Then 12 and 2. Okay. Now, this one, I'm going to say that this one has a value of 1. And notice I can have a 1 here in value and a 1 here in value because the value of each item in items is unique. So I can have the same value, at least according to my understanding as it is now. Okay, and we're going to have a weight of 8. Then here we're going to have 87 with a value or with a weight of 6. Okay, then we're going to have another one which is 4 and 88. Cool. So now I need to do a return. So I'm going to have ret, what did it call? Just ret, okay, is equal to, and now I need to have elements in here where I say 99 and 3, okay? So for this value, 99, is there any 99s in here? No. Okay, so I know that the weight is just for the value 99, there's going to be a weight of 3. Now, next element, 8. Is there another value of 8 in here? No. So 8 and 200. Awesome. Next one, 62. Is there a 62 in here? No. Let's make there a 62. 62. Okay, so now there's a 62 in here and a 62 in here. So I need to put in the value is going to be 62 and the weight is going to be 91 because it's 88 plus 3. Okay? All right, next one. We have, so 99, 8, 62, 7. Is there any 7s? Nope. So it's going to be 7 and 9. Okay. How about any 1s? Well, yes, we do have a 1. Put it here. So it has, for the value 1, there is going to be a weight of, so 13. Then for 12, for 12, we're going to have a weight of 2. And now, here's the other thing. I need to try to figure out, like, which elements did I not capture in this items 2? Do I have a 1? Yeah, I have a 1. 87. Oh, I haven't put it there, so I need to put 87 with a weight of 6. And 62, what about that? No, I don't have that one, so let's put that in. 88. Oh, wait, yes, I do have 62, sorry. So that's kind of how I have to do it. I have to say, like, oh, I've already used this 62. Okay. So I think that's what we're going to do. Now, let's look at the example, see if we're completely off base. If we are, then we need to reevaluate our methods. But if we are on the right track, then okay, cool. Now how to actually solve it. So one step at a time. First need to understand the problem, then try to figure out, okay, now that I understand it, how do I move forward and how do I actually accomplish this task? Okay, cool. So 1, 1, 4, 5, 8, or 3, 8. Okay, now 3, 1. If my idea is correct, this 3 is going to be combined and we're going to have a 3, 9. Let's look. 3, 9. Yep, there it is. All right, so 1 and 5. So this is going to be 1 and 6. 1 and 6. Okay, now 3 and 8. So this 3 should just be 3, 8. Wait. Oh, no, sorry. 3 and 9. 3 and 9, yes. So 4, is there a 4 here? No. So 4, 5. Yep, and here it is, 4, 5. Okay. So far the world is in order and everything makes sense. All right, so I think we can kind of skip the explanation because we went through the model and everything makes sense to us. All right, so 1 and 3, so we should have 1 and 4. Yep. 3 and 2, so 3 and 4. 3 and 4. 2 and 3, so 2 and 4. 2 and 4. 1, 1. Okay, so we already captured that. All right, so the world is in order. The world makes sense. How are we going to do it? So first thing that I want to do is possibly think about, okay, just being completely honest, I don't know how I'm going to solve this. So I'm first thinking, like, what would be a brute force method? Okay, brute force method, I'd have 2 for loops, and I iterate through each of these elements. So I do, for this element, this 99, I check all elements in items 2. Is there a 99? Is there a 99? Is there a 99? If yes, then I add them. If no, then I don't. Okay? Or, sorry, then I just add this singular element to my return. Okay? So the time complexity of that would be O of m times n, where m is the length of items 1 and n is the length of items 2. Is that an acceptable time complexity? Could be. I think I might code up that solution, and along the way, think about if I can find some other ideas for how I can go about solving this. So let's just start writing some code, and then we'll figure out if this is the most of. We'll think about if we can find a more efficient solution while we're coding it, and then if we're able to get it through this method that I'm thinking of, we're then going to go and check Copilot and see what it has to say. Like, ask it, hey, I did it this way. This is how I accomplished it. Can you think of a more efficient way? Right? So that way, even if we're able to solve it, we don't want to just stop and say, nope, we're done. We got it. We solved this problem. We want to always be looking for those opportunities to be like, oh, here's an interesting way to do the problem. Oh, here's a more efficient way to do the problem. So that's kind of how we're gonna do it. Let's just do a 2 for loop. So for I1, meaning element of, maybe I should call it E1, element in items 1, right? In items 1, okay. Mistyped there. For E2 in items 2. Okay, what do we want to do? All right. If E1 and we want to look at the value, right? So that is going to be the 0th index is equal to E2 at the 0th index. So we're checking the value for both. So the 0th index in this element and the 0th index in this element, are they the same? If they are the same, what do we want to do? We want to add this item. Okay, so, or we want to sum this item together. So we can access the weights by doing the E1 indexed at index number 1, but where do we want to store this? Okay, so we also need a return, right? So okay, so return dot append, okay, and what are we appending? We're appending value first, so E1 indexed at 0. So we're appending two things, and remember, if they are equal, like for example, this case and this case, the value is equal, so I want to append this 1 first. That's what I'm doing. E1 indexed at 0, so E1 indexed at 0 here. It's the first, and then second element is the weight. And what is the weight? It's E1 indexed at 1, right? Right there. E1 indexed at 1 plus E2 indexed at 1. Not a dictionary. Indexed at 1. Okay. So we're here. We're going to get this element, which is 5, and this 1, and we're going to get 6. So we're going to append 1 and then 6. Okay? Now, I'm trying to think ahead a little bit, and I need some way to mark that, hey, I used this element here. Please don't reuse it. Am I allowed to change items too? Can I do, and I don't know about the Python syntax, I'm not sure if this is actually going to work, but can I do something like, I also don't know if it's going to mess up this for loop, but I was thinking about doing something like items 2 dot remove E2. I don't know if I can do is this, how does Python actually store this? Is it like a memory location or is it just the raw data? I'm not exactly sure. I don't know if we can do that. So if it, okay, so if they are equal, we add the element and then we remove this because we don't want to, once we finish going through all of the elements in items 1 and checking it against all of the items in items 2, there's going to be some elements in items 2 that we haven't added yet. And then we need to singularly add those by themselves. So I want to just remove the we need to remove this one. So we want to say like, okay, there was no 3. Let's pretend that this didn't exist. There was no 3 value. So we need to add a 3. Or we need to add this singular 3, 1. If this remove doesn't work, I'm thinking that there might be a solution that utilizes like a dictionary such that I can do an O of 1 lookup and be like, hey, are you in or are you out? But I'm not entirely sure how to do that right now, so I'm going to continue with this implementation. If Python doesn't like what I'm doing, then we're going to have to change some stuff. But as of right now, this is the direction I'm headed. All right. So if they are different, what do we want to do? Nothing, because I'm looking at each of these elements, right? Like I'm looking at this 1, 1, and then I'm going to look, is this a 1? No, so I don't want to add it. And I also don't want to remove it. I want to keep it there. Then I'm going to look at this one. Is this a 1? Yes, it is. So I want to add it. Add it together and then remove this from the array. Or from items 2. Okay. And then it's going to come back up to this for loop and go to this element and then recheck like, hey, are you a 4? No, you're not a 4. And then this is removed. It's gone. So then it's going to say, okay, well, I'm done. And then it's going to come to this one. So I need some way to determine like if let's say that this 1, 5 was not here. I have this 1, 1. And I check, check, check. I don't see another 1 in items 2. I keep checking. There is no value of 1. So I need some way to determine like, hey, I didn't find this value in items 2. So add it by itself. So I'm going to say item found is equal to 0, so it's going to be false. This is just a Boolean variable. Now right here, I'm going to say item found equals 1. So I set a flag like, hey, we found the item, don't need to add it. So now, once this one finishes, once I go through all of the items in items 2, if not item found, so if I didn't find any matching item, I need to add this singular item by itself. So ret.append, and what am I appending? I'm appending E1, so the current element, and this should be a list, right? So I'm going to space this so it's a little bit more clear. I'm appending, what am I appending? This list of E1 indexed at 0 and E1 indexed at 1. Now, why is that? Well, it's just I don't need to add anything. I don't need E1 of 1 plus E1, or sorry, E1 indexed at 1, meaning the weight, plus E2 indexed at 1, meaning E2's weight, because there is no E2 that matches the same for the same value. So we do this, and then we come back up here, we set this flag back equal to 0, and check for the next item in items 1. Okay, now I need to, once this loop finishes, assuming that this statement here actually works and removes each element that I add to the list, return or items 2 now only contains those elements that don't have any matching values to item 1. So now I need to just singularly add all of the values, all of those elements in items 2 that remain coagulated together with items 2. So let's now just loop through items 2. So for E2, right? We're just going to go back, or let's just call it something different. So element in items 2. What are we going to do? We're going to ret.append, and what are we appending? A list and element of 0, element of 1. So we're just appending that value into our return. Okay, now we return. Let's run this, see if it works. If it does, I'm going to be very happy. And it doesn't. Okay, I wasn't expecting it to fail on that line. I was expecting it to fail on this line. Oh, we didn't even... Of course it's going to fail. We didn't even... Ret is an empty list. We didn't declare it. Okay. It's probably going to fail on the next line. Okay, well, it didn't crash. I was expecting it to crash on this line, but it didn't. So does that mean that our logic was wrong? Or is this operating in some way that I assumed it operated on one way, but actually it's not operating the way that I thought it was? So we're going to have to do a little bit of investigation here. All right. So 4, 5. Okay. Output is 4, 5. 4, 5, 3, 9. 4, 5, 3, 9. 1, 6. It's the same. It's the same. 这是什么情况? It's the same thing. Just I assumed that the order could be... I should have read that little note there. Ret should be returned in ascending order by value. Okay, well, I think we actually solved... So, I didn't read this part, right? And so I was solving this question, and I think I got the underlying logic correct. So I solved this problem, but I wasn't solving the actual problem. I think that in Python that there is some way to... That's more of just like a syntax, or this is not a logic question, so I have no shame to go to ChatGPT and ask it, like, I realized... So what I'm going to do is first see if there's a function that sorts a list based on a specific element or a specific index within that list. So I want to sort this list, this two-dimensional list, and I want to sort it in ascending order by the first element, so the 0th element. So I realized that I need to sort this list based on the first element in the 2D array ret. Is there a quick Python method that accomplishes this? Don't worry if my law... should I say that? Let's just do this, and then because we also need to figure out, like, is there a more efficient way to solve this? Because especially with this new piece of information, is there some trick that we can do? Could be. Okay. Let's come back to here. I see what you're getting at. Sorting a list based on the first element is straightforward in Python, thanks to sorted. Here you can use a lambda function. Oh boy, lambda function as the key to sort your return list. Okay. So ret sorted. Wait. What? What? What is this? What? Key equals lambda x. What? Okay. Let's ask it. This is what I mean by it's really fun to be able to go and just explore and see what you figure out what you don't know, because all of a sudden I happened upon these lambda functions, which I'm curious, is this like a JavaScript anonymous function, the ones that have the callbacks, or something? Is there something like that that's happening? So we're going to investigate this, and we're going to learn along the way. Awesome. So I guess I am not very familiar with lambda functions. Can you explain more of what this specific line does and how it works? Okay, let's investigate lambda functions, and then we're going to go back to the logic and see if there's more efficient solutions. So we're not losing track of our overall thing, but we found something very interesting, and we need to, like, get it, you know? Of course. Let's break down what this line does and how lambda functions work in Python. Awesome. Okay, so here's the line in question. All right, so sorted. It is a function. The sorted function returns a new sorted list, so we're capturing it here, from the elements of any iterable, okay? In this case, ret. So ret is a iterable, okay? Default sort. By default, it sorts in ascending order. Okay, and that's what we want. We want ascending order. Now, key equals lambda. X colon 0th element of x. Okay. The key parameter is used to specify a function of one argument. The key parameter. Oh, we're passing in a parameter to the function. So it's like when you call a method, you have like For example, here, when in my project that I'm working on, I'm trying to find an example, like optimizer. Did I say like a default value, whatever, right? Like I have learning rate equals 0.01. So I'm passing in kind of a parameter here. So there we go. I think that's kind of what's happening here. Like key, this is not part of the lambda function itself. It's just key equals this. Okay, we're just specifying an optional parameter to the sorted function. Okay, I think that's what's going on. Now, what parameter are we passing in to sorted under the name key? So key is a parameter. What value are we passing in to sorted that represents the key? That's the question we're asking. Okay. Is specified one. So, okay. The key parameter is used to specify a function of one argument that is used to extract a comparison key from each list element. Here, key equals lambda x is used as this function. Okay, so lambda function. Now we actually get to the lambda function. A lambda function is a small anonymous function, here we go, defined using the lambda keyword. They're often used for small operations that are used temporarily or just once. Okay, so lambda arguments expression. Usage in this line. Lambda is kind of declaring like, hey, I'm going to do an anonymous function here. Watch out. Here we go. Lambda. Then our arguments. Okay, in this case, x is our argument. And then expression is x of 0. Means for each element x in ret, the key function extracts the x0, which is the first element. Okay. What is the time complexity of... Oh. Tim sort? I didn't know that there was a Tim sort. Since Tim sort performs very efficiently in practice, it is a great choice for many sorted tasks. Oh my gosh. I want to learn this Tim sort. Yo, here we go. I didn't know that there was a Tim sort. It's not time sort. Yeah, it actually is. Okay. It's actually Tim sort. Best case when the list is already sorted. Okay. Average case and worst case in log n. Okay, cool. So let's do it. So let's do this. Return. So ret sorted is equal to, and let's see if we can remember how to do it. Sorted. Okay. Now sorted passes in two arguments, an iterable. So here's the iterable, and then we want key is equal to, so then key lambda, okay, then I remember just from memory it was like this. Like this. But I'm trying to just kind of put it in my head what is actually going on here. So we have x which is the argument. So I think it's passing in the specific value of ret. So this sorted will take this iterable, and for each iterable, it will put it in as the argument and get back something. This is the return value, and then sort it based on that. Then it returns back this list and sorted by this index. Now I can just do return ret sorted. Okay. And as it said, this line of code here is time complexity of n log n, and this time complexity up here is m times n. So this one has a much larger time complexity, so we're kind of free to use anything under that m or m times n boundary, and this falls well below that boundary. So let's see if this works. Okay, but as we see here, not efficient. Most people are doing pretty good up here. So we're going to go back to GPT and say, all right, here's how I did it. Here is how I did it. Can you think of more efficient, more time efficient, time complexity efficient ways of doing it? Okay. So it says my solution is functional but can be improved in terms of time complexity. Removing elements from the list within a loop can lead to higher time complexity. So it doesn't like that I am doing that remove. What I'm thinking is possibly each time I remove, it has to check each element in this items to list to find the specific element here. And that's why I was kind of wondering, like, if this is just a memory location, then it should be an O of 1 lookup. Just bam, get the memory location, remove that, take it out of the list. But okay, how is it doing it? So it is using a dictionary, like I was saying. Like, okay, there should be some way to do a dictionary. So let's so we're doing a default dict, okay? So I also notice we're not doing two for loops, or they're not nested. Sorry, we are doing two for loops, but they're not nested for loops. So we have a for loop here and a for loop here. So count values from item 1. So we're getting each element, item values. Oh, I see. Oh, okay, that's actually really, that's a much smarter way of doing it. I completely overcomplicated things. I can just use a default dictionary. And what is the functionality of a default dictionary? It is going to first have nothing in the dictionary. Then I'm going to try to access a key, and if the key doesn't exist, it's just going to create that element for me. So I am going to say, like, all right, default dictionary, and my value is going to be the key. That's what I want to see. Like, is there any other element in this dictionary with the same value? If so, then I want to add the current key. So you have the key value pair, and this can get kind of confusing because value is the first element in each of the items, and then in a dictionary, And then in a dictionary data structure, you have something, so like my dict equals, and then like you have like this where it's key value. So this is kind of the same word. But let's so we're doing value, which is actually the key. This is why I said it's a little bit confusing. So if that if how do I want to say this? If this element, okay, I'm just going to call this an element. If this element is not in the dictionary yet, we add that element. We create an item in the default dictionary of that element, and we add the weight as the associated value. And I'm using value in the sense of a dictionary, okay? So then at the end of this line, so once we have finished this for loop, we're going to be right here, right? We're at this line right here. We just finished the for loop. Okay. What is the state of our dictionary? It is every single item in items 1 has been added to the dictionary, and its key is the element. Its value is the weight. Okay? Then what do? We just loop through all of the elements in items 2. And we take the element and say, are you in the dictionary already? If you are in the dictionary, then we just access that item and add to it the weight. If it is not in the dictionary, then what we do is we add it to the dictionary with the associated weight. Then we come here, we sort. Okay, and they're also using lambda. This looks like a little bit more complex of a call. I'm trying to figure out why this is. Oh, we also need to, because right now we have a default dictionary, we need to turn it into a list. Okay, got it. So we're doing sorted. Good. What are we sorting? Okay, so this is our iterable, remember? This is an iterable, and we're like casting it as, or we're like capturing it as a list with these two brackets. Okay. Now what is in this bracket? So we're creating a list. So for value weight in items counted dot items. Okay, so what's happening here? Item counts, which is our dictionary. Okay, so dot items, what does this do? It returns the key value pair in a dictionary. So what we're doing is we are going through each of the elements in our dictionary and capturing the key and value. Then what do we do with those two elements? Well, we store it in a list of this one here, that one there. Okay? So at the end of, once we've iterated through all of the items in items counted, we are going to have a list which is full of other lists which have the value and weight. Okay? Then what do? That is, this two-dimensional array is going to be our iterable. And each element, so we have a list, and this list contains smaller lists inside of it. So what is our iterable? It is, each element is going to be one list. List, 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 list. Okay? So that's what we're passing into this sorted function. Now we have to use a lambda function, or a key. We have to pass in a key parameter to the sorted. We have to say, hey, what are we sorting it by? Okay, take this x, so this is our input parameter, and that's going to be each of the iterables, and each iterable is this right here. Here's one iterable, it is a value weight, and then the next one is also going to be a value weight, the next one is also going to be a value weight, and what do we want to sort it by? So this is our kind of return. So we take in this iterable right here. Each time we loop through an iterable, we get one element, and we pass it in here as our argument, and we return x0, which means value. So we return this from our lambda function, and that's what sorted sees and says, okay, this is what they want me to sort by. It returns a sorted list, and then we return the sorted list. Okay, so that's how they're doing it. Now, this is going to be a time complexity of O of n. This is going to be a time complexity of O of m. Okay, so right now we have these two lines together are going to be time complexity of big O of m plus n, not multiplied, plus m plus n. Okay, now what did we say that this sorted was? It is going to be, well, first off, we need to figure out what is the time complexity of this statement here. So we're just looping through each of the items in the dictionary, which how many items are in the dictionary? Well, it's m plus n, so that's the same thing. So we don't need to bump up our time complexity in this problem yet. Okay, cool. So that's how many elements are now in our return, or in the list that we're passing into the sorted. What was the time complexity of sorted? It was n log n. Okay, n log n. Now, what was n? N was the value that we pass into it. And how many elements are in our dictionary? M plus n. So actually, this sorted is going to be big O of m plus n in parentheses multiplied by log of m plus n. So it's significantly better than m times n because we have a log in there and we have two additions. So much better time complexity and also much simpler solution than mine because I have to have this Boolean flag that I'm keeping track of things like did I add it, did I not, and then I have to remove things and it gets complicated. Also, I don't know if does this affect items 2? Like is items 2, that's a good question for Python or for GPT. In my solution, does Python change the items to list I don't want to say from the calling function, but change the list in the external calling function, like it, because it's passed by reference, right? So I'm manipulating, yeah. So I mean, my solution has a few little problems in it. So I'm glad that I was able to see this one. So that's kind of what I wanted to do. Today I got to learn about lambda functions, got to understand how they work a little bit better. I also got experience with number 2363. Okay, this specific problem, but also kind of the a new perspective, a new problem, just every day, if you keep looking at problems, looking at problems, looking at problems, eventually you're going to get better and better. And I can guarantee you that what I did just now, my performance in this video is so much better than it would have been 4 months ago before I started doing Leetcode. If you, because I knew how to program 4 months ago, right? If you would have asked me, oh, do this problem 4 months ago, I would have been, I have no idea. Even though I know how to program, I know computer science, I know software engineering, I know embedded systems, I know firmware, I know hardware, right? Like, I know these concepts. If you would have asked me to do this, I would have been drawing a blank. But by seeing a whole bunch of problems, it's very interesting how your brain is starting to like, oh, I think I kind of see a path forward. It might not be the optimal, might not be the best, but I could immediately see a solution or a pathway forward. Kind of interesting observation that I just wanted to say because I remember when I started Leetcode, I would look at a problem. First off, I wouldn't even understand what the problem was saying. Second off, even if I did understand what the problem was saying, I wouldn't even know how to do the brute force method. And I would just be like, I don't know. I don't know. I don't know. Kind of like that. But I think there's huge value to continuing to learn, 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 learn. Like, look at a problem, see it. If you can't solve it, that's okay. Just try to understand the solution and then go to the next problem later and just get that practice, get that repetition, just learn, learn, learn. So anyways, thank you guys so much for watching this video. I hope you enjoyed it. I hope you learned a lot as well. So tomorrow I will be making another Leetcoding video, as I do. I make Leetcode videos every single day, at least one problem every single day. So if that is something interesting to you, you can subscribe to this channel. That would be amazing. I think I hit 400 subscribers today. I can't believe it. That's incredible. Thank you to everyone who subscribed. That's amazing. So, yeah, subscribe if you want to. If you don't, that's fine as well. I'm glad. It, I'm glad if you are learning. I hope you are. And yeah, I will see you guys tomorrow. My name is Timothy Lee Grant, and have a wonderful day.